Math 8, we're going to look at scatter plots again today. We're going to look at trend lines again. Remember the trend line being a prediction based on the data. And we're going to look at making a good trend line over data today. Real simple. Just taking scatter plots and fitting a good line over the data, what makes a good line and what makes a bad line. So go ahead and try to think what makes each graph different from the others. So like what sets each of these four graphs apart? So think about that for a minute, and then we will go in and write stuff down below. This is your pause time. So I'm thinking top left. Let's see, so I'm looking at this one, top left, top right, bottom left, bottom right. Well, if I'm looking at the top left one, seems to be the only graph that goes up or has a positive slope. The rest of them, as you go from left to right, like this trend line here goes down, this trend line here goes down. This graph, bottom right doesn't have a trend line, which is the only one that doesn't. So bottom right does not have a trend line on it. But it still seems like if I were to draw a trend line, I would draw a negative trend going down. So let's see. I see top right. Well, the top right one, this other horizontal bold line here, turns out to be the x-axis. The top right is the only one that I see that goes below the x-axis, so has negative y values. Maybe that's a company model showing how they're losing money. And let's see, so now I'll move bottom left. Well, bottom left. If I look at bottom left, I see a lot of data that's really far from the line. I see at least 3 points in bottom left that are really far from the graph. So maybe I'll say has outliers, question mark. And let's see, what else could I say about bottom left? Feel free to add stuff, email me, let me know what you could add to bottom left. I mean, it has the largest scale. It goes up to 100 on the y-axis, which makes its outliers even more because I'm counting by larger numbers on my axes, so my outliers are even farther away from my predictions. I'll go with that. Let's see. And also my trend line for the bottom left goes through exactly 2 points. Trend line goes through exactly 2 points. And the top left one does too. It goes through those 2 points. Doesn't really have to, but it goes through those 2 points. And my top right only goes through 1 point. And even that 1 point, it seems like it's kind of off center. So top right, trend line only goes through 1 point. Trend line only goes through 1 point. Now keep in mind, the trend line does not actually have to go through any points. So when you make trend lines today, don't be thinking it has to go through 2 points. It does not have to go through any 2 data points on your graph. That is not the point of a trend line. The point of a trend line is to fit the typical path. And none of your points might be exactly typical. So you could make your trend line pass through all of them, but not go directly into any of them. Okay? So let's keep looking. So fitting lines. Our goal today is to sort of look and see how you can fit a line. If there's any day when you could print out a lesson and try it, this is a good one. A good activity you could even use. You could use like a piece of spaghetti, and you can sort of try to fit it over the middle of the line. So you can experiment with drawing lines to fit the data. And you could sort of like take it at home. You can take a piece of uncooked spaghetti. I have to say it's kids in school every year. Don't eat it. That's gross. Uncooked spaghetti is not that good for you, and it can be dangerous, so please don't. Take a piece of uncooked spaghetti and try to make it, or try to lie it down so it passes through the middle of the data points. you want to be close to most of them and have some above and below and about the same number above and below. So that's like your instructions for trying this out at home. If you have the materials, go for it. If you have like anything sort of quite narrow, like a nail, or okay, all these dangerous things you can use. I don't know, something like a pencil would work, but it'd be kind of too big. I'm going to just use Microsoft Word and use the line tool because that's what I do. So I'm going to insert a line, and I'm even going to color it like orange because that's kind of close to spaghetti. It's not really, but I'll make it orange. So here's my spaghetti. I'm going to take my trend line, I'm going to put it over here. And I'm going to try to move it around to make it actually go through all the data. So I'm going to take it and sort of move it around here. And I can take this trend line and I can drag it around and see if I like where I'm putting it. So like I'll leave it there. And if I look at that, I think, well, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 10 points below my trend line. And I have, let's see, that one's pretty much on it. I'll say 1, 2, 3, 4, 5, 6, 7, 8 above it. So I have slightly more below. If I look slightly downward a bit, that's too much. Microsoft Word doesn't like small movements. It moves things a lot. But if I maybe make it a slightly less steep slope, and maybe I'll make the bottom come up a little bit too. Maybe I like that as a better fit for my data. So you can really sort of play with the line and make sure it goes right through the middle. Now keep in mind, you are not starting your line at the origin and just drawing it up. That is an absolute no. You want your line to fit an accurate model of the data. So if I have this line here to the right, this line is not a good fit because all the data is above the line or on the line. It goes through like 4 points, which is nice, but all my data is above the line, so it's not good. I want to pass through the middle and kind of follow it. Everything's staying fairly close to the line. And again here, even with this, I have a lot of points at the end that are kind of above my line, so maybe I'll move the end up a bit. And maybe I'll move this top end down a bit. And that seems a bit better. That doesn't look bad. Let's see, I have 1, 2, 3, 4, 5, 6 below, and 1, 2, 3, 4, 5, 6, 7, I have 8 above. So maybe I'll move it ever so slightly upwards. Yeah. I don't know. I don't know if I even like that better. That rule is not a very good rule. I kind of like this. Let's see, that looks okay. Maybe I'll move this a little bit. It's not bad. And really, it's all just sort of trial and error. In school, we have a lot of fun with the spaghetti pastas. You could build your own. Your whole table could have the graph, and you could all compare who did the best job of laying it through all the data. There's a lot of different things you can do with it. So have some fun with the spaghetti if you have it. And if you don't, well, then have some fun with watching my video. And just give it a try. So here's 2 copies of another scatter plot. Experiment with drawing lines to fit the data, and pick the line you think best fits the data. So, oh dear, something bad happened. Okay. I'm not showing that video because it's an extra video to watch, and I know that my videos are way better than everyone else's, so we're not going to bother with anybody else's. Compare with a partner. No, don't do that. So here's more scatter plots. Above. Let's see which line I think is better. So let's think. I have these 2 lines that I made. I have left and I have right, and they're pretty similar. They're actually almost identical. It's very hard to tell the difference between them. I think I like the left better. I think the left line fits closer to more of the data than the right line, especially more towards the left. So I'm going to say I like my left line better. If you said the right line, they're both pretty good lines. So let's see, I'm going to draw a couple more down below. And you want to make sure that we're getting our spaghetti, our scatter plots through the data. Now down here, I notice that these points are a lot farther apart from each other. So it's kind of interesting to sort of think about where I would put this line. Like that seems to go through the data. But then again, so does like this. So both of these lines seem to kind of fit through my data, and they both seem to kind of fit the pattern of what's happening here. So I want you to take a minute and think about which line better fits the data. So when you talk about how far points are from the line, like I'm talking about how far this point right here is from the line, I'm thinking about vertical distance. So how far up or down is it from the line? And that's because we're comparing the predicted y value of the line versus the actual y value we saw in the point. So I'm looking to keep all those points vertically close to the line. So when I made this graph here, I think what I'm going to end up with is a lot of these points with a significant vertical difference. Very few of them have a small vertical difference. Where this one over here, I have a lot more points that seem vertically close to this line, like especially the beginning. The end, not so much. Maybe I'll move the end up a tiny bit. I don't know, I'm just feeling more of this right line over here. Typically, with more scattered data, these steeper lines tend to be not so good. Yeah, I see a lot of points where a very high distance from the graph. So I'm going to say I think the right line works better here. And again, part of your exit step today is only 2 questions, but you have to actually explain which line you pick, like which of the 2 lines that are there better fits the data. So we're going to sort of give reasons for that. So it works better here because it goes through the middle of the data. Most data is relatively close to the line, and the other line has more points that are farther away from the line. Some of all the stuff in different color, little pieces. That's a green piece. So more points that are farther away from the line means that those predictions are not as good. This line is doing a worse job of predicting points because a lot of points are fairly far. Like there's a lot of points that are almost 10 away or more than 10 away. Whereas I feel like my graph to the right doesn't have as many. Like towards the end, I think I have more, but that's same over here too. I mean, I have a couple that are close here, but all these ones are like 10 or more away. Whereas this graph seems to fit more the middle. I have like maybe like a 5, maybe like a 5, maybe like an 8, maybe that's 10, maybe that's 8. Whereas this one I have like some small ones, then some that are like a lot that are like more than 10 away. So more points that are farther away from the line is a bad thing. If you have a lot of points that are close to the line, a lot of points that are right near or right on top of it, that's also good because that's a lot of data that got predicted really, really well. So that's a good thing to have in your trend lines as well. And I see more of that in my right line. I have 1, 2, 3, 4 points that are extremely close to the line, and I have another 1, 2, 3, 4 that are like right next to it. Whereas over here on my left side, I have 1, 2 that are directly on it, and I have like 1, 2, 3 that are really 4 that are like really close to the line. So I have like a solid 2 more really good points that are predicted on my right line. Doesn't mean that this is the right line, but I think it's a better line to use. So more data is close to the line, and less points are really far from the line. There are few points that are very far away. All right, so those are our real main things you want to look for. So what makes a line fit data set well? Let's look at our lesson summary. We'll get some good wording from that. They're here. So basically, when a function fits data well, there's a linear association. We're talking about linear lines, straight line, ruler straight lines. So if the line is a good fit, that's summary's not going to help. If it has a good fit, the line is going to be close to a lot of the data and not too far from any of the data. And you want to sort of follow the same path of the data. And here's another sort of thing to keep in mind. This is more advanced, but like it comes up a little bit down the road. So if I have this line here, if I change my right line to this, on the left side of my graph, almost all my data is below the line. And on the right side of my graph, most of my data is above the line. So that would indicate that line is still not good, even if it's the same number of points below and above. I don't want it to be like, well, the first part of my line is above the data and the second part's below the data. I want that to be fairly consistent, like I'm more likely to have I don't want to say I'm more likely to over-predict early on or under-predict later. So, again, more advanced, but otherwise that would kind of indicate that your line is kind of skewed a bit. It's crooked. Anyway, I should probably just hit undo for that. Whatever, that's fine. So, this is kind of like where your exit slip is. So we have the same scatter plot and two different trend lines. The same scatter plots show the year and the price for the same 17 used cars. And each scatter plot shows, again, the different model. So it's a different model because it's different trend lines. You can tell. This trend line seems to start lower and go up steeper. This one over here on the right starts higher and goes up more shallow. So for how many cars in the model does the model in diagram A make a good prediction? So a good prediction is basically how many points are close to the line. I'm going to count those. And then how many cars does it underestimate and how many cars does it overestimate? So how many cars, let's see, if my model underestimated, that means points are above the line. So how many points are above the line? And then if the model overestimates, that means that the line is above the points. So we're going to look at how many points are below the line. And we're going to do the exact same thing for diagram B. Okay? It's going to help us sort of think about what makes a trend line good and what makes a trend line bad. Because if we can ask ourselves these sort of scaffolding questions, you can start to think, oh, this model is really overestimating a lot of these car prices, whereas the other one is sort of equally over and underestimating, so the left model, one model is more trustworthy. So try that. So part A, how many cars does the model in diagram A make a good prediction? How many points are close to the line? So I'm going to say 1, 2, 3, 4, 5. That's bored. I'll say 5. I'll say 5 points are like really close. And again, you might have said 6, and I've said a different number based on your judgment of close. Just try to keep your judgment of close the same for each graph, because you might have said a different number, but hopefully you're still getting the same conclusion. So diagram B, for diagram A still, we're looking at the left. For how many cars does the model underestimate the price? So how many points are above the line? So the model is the trend line is the model. So how many cars is that underestimating the price? Let's say I have 1, 2, 3, 4, 5, 6, 7, 8. So 8 points above the line. There are, just count them, 8 points above the line. And how many cars does it overestimate the price? So let's say I got 1, 2, 3, 4, 5, 6, 7, 8, 9 points are below the line. So that's pretty good. That's as close as you're going to get for an odd number of cars. 1 is directly on the line. That's the closest you're going to get. Okay, so now let's look at diagram B. So for how many cars, I'm going to make this 2 columns and hope that doesn't ruin everything. Just so we can see everything. Not great. Can I change the margins? Yes, there we go. Okay, cool. So in diagram B, how many cars does a model in diagram B make a good prediction of its price? So diagram B. Okay, so to keep in mind, I said that these 1, 2, 3, 4, 5 points were good predictions. I did not include that one. So I'm not including that one. For diagram B, it looks like I have 1 car that was pretty good in its prediction of its price. So it looks like I have 1 point was well predicted. So already I'm not off to a great start here. I'm looking like this line is not going to be a great fit because it only was really close to 1 data point. And how many cars does the model underestimate the price? So how many points are above the line? 1, 2, 3. Yikes, only 3 points are above the line. You can tell by looking, this line is above most of the data. Most of the data is well below this line. So 3 points are underestimated. So that means we have, if you're doing your mental math, 17 total cars. 3 are underestimated. I got 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 cars are, what just happened? 14 cars were overestimated. Okay, so that sounds like a dealer trying to rip people off. They're overestimating the value of most of their cars. Okay, so we can see the discrepancy. Over here in diagram A, 5 points were really close to that line. 8 were above, and 9 were below. So we have that good thought process there. Okay, we have about the same numbers here, 8 and 9, the closer you're going to get. And 5 are really, really accurate. And the rest are like a little scattered. Like you can maybe imagine, like maybe they can move the line up a smidge to get this point a little bit closer. Maybe bring this down a bit. But these two, it's going to be hard to match these two. But over here, you're like, okay, these bottom points are nowhere near this line. And like, why does it go up here at the end when the data clearly goes down here? This line is a bad fit. So you should be able to tell by looking that it does not follow the path of the data at all. Well, okay, it's not terrible, but it's pretty bad. Only 1 point was well predicted. We only classified 1 point as close to that line. And even if you were like broadened your horizon and said like, well, maybe this one's pretty close, maybe this one's pretty close, that would have made this graph over here, that would have given us at least 1, 2, 3, 4 more points to say we're close. So if you're broadening your definition of close, the left graph would still win. Okay? And really a big thing that's going to help you is like how many are on each side of the line. 3 above and 14 below, not a good fit. Okay, let's see. Question 2, how many cars the prediction made by the model in diagram A differ by more than $3,000? And how about diagram B? So $3,000 is 1 square. So $3,000 is 1 square on the grid. So how many cars are farther away from the line than 1 grid box? So in diagram A, let's see, how many are more than, or let's see, more than $3,000. So how many points are far, basically was asking. How many points are far away? So more than 3,000, let's see, that one's exactly 3,000, we're not going to count that one. That one's not really either. Okay, 1, 2. That's a close one. I'm gonna say no. Yeah, I think 900. So 2, 3. I got 3 points. These top 3 over here are more than $3,000 away. So I'll say I have 3. The top 3. Are more than 3,000 1 full box away. And again, if if you were like, nah, that one's more than 3,000, or that one's more than 3,000, that's fine. Just remember to use that same metric for the next graph. So you got 3 that are real far away from me. So in graph B, I'm looking at, all right, these first 2 are already more than a block away. So I got 1, 2, 3. This one's way down here. No. I'll say no for that one. 4. No. 5, 6. No. Say no. I'll say no for those 2. So we have 6. Because these 3 are all within. We had 6 for diagram B that were more than $3,000 off. And if you're shopping for a car, $3,000 is a fairly big margin. Unless you're like looking real nice, like brand new cars, like where $3,000 is like not terrible. If you're looking at used cars, $3,000 can be quite a bit difference in price. Okay, let's see. Okay, so another thing you can look at is how far away are the farthest points. So the metric you can use to determine which line is better. Which model does a better job of predicting the price of a used car? And this is literally used cars. So yeah, I'm glad we were talking about that because I forgot the problem was about used cars when I mentioned the used car example. But yeah, if you're predicting that this car is going to sell for, let's pick like this point here. If you're predicting it's going to sell for about $19,000 and it only actually sells for $16,000, that's a huge gap. That's like 20% of its value, or 20% of a price difference. That's a huge gap. So that's a pretty bad claim to make. So which model does a better job? Model A does a better job, hands down. Hopefully I have now convinced you. I think I have. Okay. And again, just trying to see, does this line fit the data well? And if it doesn't, try to draw a line or imagine a line that would fit it better. Where would you put that spaghetti? So go ahead and think, does this line do a good job of fitting the data, and can you make a better one? Okay, so if I'm thinking about the logic I used before, this line has 1, 2, 3, 4. It has a lot of points that are really close to the line. It's got that. A lot of points are really close to it. But there's a major problem here. I only see 4 points above this line. I see it's below 4 points, and I see it's above 15, 16 points. I lost count. So it's really far from these points down here. These points down here are more than 1,000 units away from that graph, which is a major, major problem when it's so close to these ones up here. So this line is not fitting that trend very well. So what I'm going to do is I'm going to take that line. You should probably think to yourself that you're scooching it down a little bit. So maybe it's going to move down here more. Now I know what you're thinking. I'm not close to I'm probably closer to a few points here. I'm not as close to some of the points on this graph, but it's still more towards the middle of the graph. Like if I put it up here towards these, I'm not accounting for these points. And if I put the line down here, I'm not accounting for the above points. So sometimes in the middle, even though you're somewhat far-ish from many points, you've sort of split the difference. You're like, well, I'm 1,000 from here, but I'm also 1,000 from here, or 1,000 from here. So it's kind of like you compromise a bit. All right. So that's our lesson with the trend lines, fitting it close to the data, keeping it in the middle, if possible, keeping about the same amount on each side of the line, stuff like that. Your exit slippage should hopefully be pretty straightforward. Just explaining in like 1 or 2 sentences if your line's a good or a bad fit. Real quick one today, 4 points. So yeah. Again, here, does this line fit the data well? Well, maybe on first glance it does because I've got a bunch above and a bunch below. But remember what I said before about it being a little bit skewed. This line here is a bit weird because at the end it's above everything, and then at first it's below everything, which isn't really great because that means it's it's under predicting at first and over predicting at the end. So if I draw something like this, I'm now going through the middle of everything, and I see I'm actually kind of closer to a lot of the points, and I'm over predicting and under predicting equally as I go. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 below, and 1, 2, 3, 4, 5, 6, 7, 8 above. Oof, maybe I should lower it a bit. Maybe I'll lower it like a bit here, a bit. I don't like that though. I'll put like here. Maybe I'll stick with having a couple more above. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is pretty good. I'll leave it here. So maybe more like that. It does take some refining, take some getting used to. And maybe I still want it up a little bit, even if I put more below. Maybe I want it like that. All right. You won't have to actually draw lines in your homework. It's just a good thing to get used to, like seeing what line fits over a data set better. Okay? Enjoy your exit slip. Should be quick. And then have a wonderful weekend. It's your last math class of the week.